So we're going to go ahead and get started. So if you can all help me welcome Andrew for his talk, Docker and Databases.
Thank you very much. Hi there, everyone, and welcome to this talk on Docker containers and databases. Quick bit about myself. My name is Andrew Prusky. I'm a SQL Server DBA and Microsoft Data Platform MVP. Originally from Swansea, Wales, but I've been living in Dublin, Ireland for about 5 years now. My Twitter handle @dbafromthecold and my email address dbafromthecold@gmail.com are on the slide there. So if you have any questions after today, please feel free to get in contact. I'm always willing to talk about this stuff. And also I'll be in the hallway tracks a little bit later at 2 and 3. So if you want to join me there, we can have a more talk about Docker containers and databases. My blog's there as well, dbafromthecold.com. Posted multiple articles about running Docker containers and databases, some of which I'm basing this session on, some of which go into a little bit further information, so you're more than welcome to check that out as well. And then finally, my GitHub account is there. All the slides and the code for the demos I'll be running will be up there, and I'll post a link to that at the end. So, onto the session. I want to tell you a story. And that story is about a Welsh DBA sitting in his office, surveying his production environment. Everything looks fine. He's happy as Larry. However, every now and again, one of the QA or devs comes over and they've had a problem installing SQL Server on one of their test VMs. Now, these test VMs have the full production stack, which means they have an instance of SQL Server on each one of them. And they're constantly blowing these VMs away, rebuilding them, trying to install SQL each time. And there's about 30 or 40 at any one case. SQL's installed via Chocolatey, which is an app package manager for Windows. And then once it's installed, they're restoring databases via a series of PowerShell scripts. Now, this wasn't the most reliable process in the world. It was prone to failure, and when it did fail, dev is left trawling through SQL error logs, Chocolatey error logs, trying to find out what went wrong, and then restarting the whole process. And I actually saw one guy blow away his entire VM, start from scratch, because he didn't want to trawl through those logs. So it also wasn't the quickest process in the world. We're talking anywhere from between 30 to 40 minutes just to install SQL and get these databases restored. And they're not big databases. They've just got data in there for references by the applications. So there has to be a better way, right? And I started doing a load of research, starting to think, how can we make this process a little bit better? And I started having a look at things like VM templates for SQL already installed, PowerShell desired state configuration. But during my research, I came across this website and started digging in to see, can we run SQL Server in a Docker container and what benefits can it bring? So I want to take you through my initial setup process now. So I had Docker installed on my local laptop using VS Code, and the first thing I did was start looking for an image that I wanted to build a Docker container from. So I just did, being a SQL Server DBA, Docker search Microsoft/MS SQL. And why isn't that executing? Minor dev problem here. Come here. There we go. Docker search MS SQL, and it brings back a whole bunch of images. And we've got the SQL Server Windows Express Edition, the Developer Edition, but I went for the MS SQL Server Linux Edition. And I pulled that down to my local machine. If I come back here, clear that. Pulled it down, and we wait a little bit. I never trust conference Wi-Fi, so I've already pulled it down to my laptop, and I have it there in my local machine. There it is, MS SQL Server Linux, 1.32 gig. Okay, for a Docker image, that's gigantic, but for a whole install of SQL Server, that's pretty good for me. So now I can run a container, and I can just say Docker run, -d, detach it, run in the background, -p, map in some ports, map in port 15111 on the host, plucked out of thin air. I just need a port that's not in use, to port 1433 within the container. And that's the default port that SQL listens on. A couple of environment variables just to accept the end user license agreement. You have to do this every time you run SQL Server in a container. And then specifying an SA password, just the default system administrator password, so I can use that to connect to SQL. Giving it a name, and then from the image. Boom. That is how quick it is to get SQL Server up and running in a Docker container. I can't tell you how much that blew my mind the first time I saw that happen. I was sitting there going, you've got to be kidding me. So we can verify the container's running. All looks good. And now I thought, okay, I've got an empty instance of SQL. Let's get some databases in there. So the first thing I looked at was the docker cp command. And that's just copying a database file into the Docker container. Nice and quick. And then I can connect in and have a look. Using the Microsoft's MS SQL CLI, which is like SQL command, but it's got IntelliSense, it's pretty cool. And then I can restore my database from my database file. Double check that it's there. And there's my database, already restored, ready to go, and that's pretty cool. However, okay, that's a bit manual though. We're spinning a container up, we're copying database files in, and then we're restoring those databases. I started looking around and thinking, there's got to be a quicker way I can do that as well. And the way I came up with, and way I discovered, was Dockerfiles. So let's create a custom image from my using a Dockerfile. There we go. And very simple Dockerfile. I'm saying from the Microsoft image, base my new image on the Microsoft image, make a directory within the container called var ops SQL Server, copy my database files in to that directory, and then the last section here is a little bit of a hack. I'm using a health check on SQL Server, and what I really want to do is just wait 10 seconds for SQL to come up, and then I can run my SQL command. Now, I appreciate there are better ways of doing this. You can write a script, I'll wait 10 seconds and spin up, but I found this the simplest and easiest way when I first started getting started with this. So I could build my custom image, and it's just stepping through each one. And now I can make sure it's there. Yep. There it is, excellent. And now I can run a container from that image. Make sure it's up and running. Looks pretty good. Wait for it to come. There we go. I can connect in. There's my database ready to go. So we've built a custom image from our Dockerfile, so we don't have to do anything else. We can spin our container up in a very short period of time, and all of our dev database is there, ready to go. So the benefits of this were our new VMs were deployed in a fraction of the time. We no longer needed to install SQL via Chocolatey. We never had to cross our fingers to make sure it worked. Those containers came up pretty much instantly with all of our dev databases there. So we didn't need to run posh scripts either to restore the databases from any files copied in. They were ready to go as soon as the container came up. Our base image was kept up to date with the production level, so all the databases in there are at the same level as production. So we know that when we spin up a container, our databases are at a known level, and then the dev can apply any scripts to take them off any TFS branch or GitHub branch they were working on. And this gets rid of the, yeah, well, it worked on my machine issue, where a database has been sitting there for a while, some scripts have been applied that haven't been applied anywhere else, which causes issues down the line. And then finally, the point there, more VMs can be provisioned on our host because each VM needs less resources. If you think about it, we've just taken, say, 30 or 40 instances of SQL off a host, moved them off onto a Docker host, so each VM is now running a little bit better because it doesn't have 30 or 40 instances of SQL there consuming I/O, CPU, and memory. Of course, we did have a few issues. The first one there, apps use DNS entries to reference a local SQL instance. Fairly standard in production, all the apps using DNS entries point to our production server. On these test and dev VMs, that was overwritten by hostname files pointing the DNS entry to 127.0.0.1, mapping it to the local instance. We no longer have a local instance, we've moved it to a remote host, and it's listening on a non-default port. And it was the non-default port that pretty much killed us. You can't specify a port in DNS entry, and you can't specify a port in a hostname file. So the solution was simple. Change the application string, right? Drop the Docker host in with the port number the container's listening into the application string, jobs are good. Unfortunately not. One of the prerequisites of this project was that we couldn't make any changes to the application. And that's fair enough if you think about it. You don't change an application that's going through your testing cycle and then deployed to production because your dev environment has changed and there's some half-praised Welsh DBA sitting in a corner babbling about Docker containers and databases. So we had to find another solution. And the solution was fairly simple. I really wish I'd thought of it, but it was the other DBA who works with me who came up with it. So thanks, John. It's using SQL client aliases on the VMs mapping to the Docker containers. SQL client aliases allow you to specify a port number. So when the dev kicked off the Docker container build, it grabbed the port number of the container that the container was listening on, dropped it into a SQL client alias. The app's connected, no changes to the apps. It still thinks it's connecting to a local instance of SQL, when actually it's connected to SQL Server running in a Docker container on a remote host. Second one there, update to existing test applications. We had a load of custom in-house applications that we could change, and buried in there was like server equals localhost, server equals dot. It's just a matter of going through and changing that. Trial and error to integrate with Octopus Deploy. Deployed all our applications via Octopus, and every single one of them deployed slightly differently. Some expected users in the database, some expected to create users in the database. So it's just a method of going through, changing the deployment process, or changing the Docker file to accommodate that deployment. Second to last thing there, new ways of thinking. As DBAs, we're kind of used to installing SQL Server, and that's pretty much it. We might make a configuration change, we might restore a database, but we generally don't touch it after that. It is this behemoth that sits there and we don't fiddle with. Docker changes that. It makes SQL a throwaway object. You don't like your container, you don't like your databases in your container, don't fix it, blow it away, build a new one. Want to restore a database in a container, don't bother, blow it away, build a new one. And it's just getting people's heads into thinking like that, because we're generally not used to SQL being, oh yeah, throw it away, build a new one. And the final one there is the one I want to talk about a little bit more, and that's persisting data. We do sometimes want to persist our data from container to container in a dev environment. We've pumped in a whole bunch of data that we want to retain, and thankfully Docker gives us a few examples, ways of doing that, So the first one there, mounting volumes from the host. Nice and simple, take a volume from the host, present it into the Docker container, create our databases on there, blow the container away, the files are persisted on the host. Generally don't recommend this method, mainly because you're putting an external dependency on your Docker container. Something changes on the host, that can affect what's happening in your Docker container. And I've seen things like permissions cause issues, I've seen Windows firewalls cause issues. So I would really recommend using named volumes instead. Create a volume within Docker, attach that to a container, make your data changes. When you finish, blow your container away. You still have that named volume that then you can reattach to your Docker container. And the final one is the one I want to talk about a little bit more, is data volume containers. We can create a container with a whole bunch of volumes in it, and then mount those volumes to another container. Make our data changes, blow that container away, but we've still got our data volume container there, and we've still got its volumes. So let's run through that now. Let's get rid of that. Clear that out. Okay, first thing to do is create the data volume container. I'm not going to run it. I'm just going to say docker create -v my SQL data volume -v SQL log volume. Give it my container a name, data store, and I'm going to pick a different image because I don't need SQL Server running on this. So I'm just going to use the Ubuntu image. Excellent. There it is, created. It's not running. I don't need it up and running. I just need it there so I can grab its volumes. Clear that. And now I can run another container just specifying volumes from my data store. And this allows me to present those volumes from my data volume container into my new container. Up we go. Make sure it's running. Looks good. Back into the SQL CLI. And let's create a database on those two files. So I'm creating my data file on my data volume and my log on my log volume. There it is. And just to prove I'm not cheating, I'm going to create a table and insert some data. So create table, very simple, just one column ID, which is going to be an integer type, and then insert, say, 200 records. Excellent stuff. Okay, jumping out of there. Let's not be nice about this. We could say docker stop container, and that would do a graceful shutdown of all the services within that container. Or we could say docker kill, which just does whoosh, immediately stops all services. And that's what I'm going to go for, because I'm not going to be nice about it, and then I'm going to blow that container away. But I still have my data volume container there, and I can remap its volumes. So I can spin up another container, saying volumes from data store again. Connect in, might be a bit quick. Oh, nope, good stuff. And I can recreate my database. There it is. And there are my 200 records. So I've managed to persist my data that I created in one database, mounting volumes from a data volume container, creating a database on those volumes, blew away the old container, spun up a new one, mapping the volumes, and recreating my database. Excellent stuff. Okay. So the final point I want to talk about is upgrading. Docker containers make upgrading SQL Server easy. In the olden days, when I was running, I think it was SQL Server 2016, and we wanted to test 2017, I would have had to go and get the installation files, deploy them to 30 or 40 VMs, execute them, do an in-place upgrade. Or build 30 or 40 new VMs, install the new version of SQL Server, and then migrate across. And there are things out there, there's like DBA Tools, which is an awesome PowerShell open source module that allows migrating databases really, really easily, but it's still a bit of a manual process. Docker Containers changes that. We don't have to install anything. We simply spin up new containers running at the new version, side by side, get everyone to blow their containers away, remap to the new ones, and we've got 30 or 40 new instances of SQL Server all running at the higher level. And we can also persist our data if we want as well by using what's a name volume, let's say. And that's what I'm going to do in this demo now. Voila, there we go. Up. Do a bit of a cleanup. So I have my two images here. I have the Microsoft SQL Server Linux latest image, which is SQL Server 2017 CU12. I also have the MCR Microsoft.com MS SQL Server 2019 CTP 2.1, a new version of SQL that's come out. Pretty cool. I want to start getting and playing around with that. So let's create a name volume. Make sure it's there. There's my volume. And I'm going to run a container with 2017 mapping that volume in. Jump into the CLI. Might be a bit quick. There we go. There's my version, 2017 CU12. I'm quickly going to create a database. Oh, what's happened there? Haha. Do you mind? There it is. Into the CLI again. Aha. And there's my database created on my name volume. So, side by side, not touching the old container, just going to spin up the new one, running from the new image. Make sure it's running. Stopping the old one. Connecting into the new one, which is running SQL Server 2019 CTP 2.1, and I can recreate the database, and that's not playing ball with me for some reason. And again, there we go. And there's my database persisted from SQL Server 2017 to SQL Server 2019. And I've upgraded that, apart from thank you demo gods. Coming out of there and doing a bit of a cleanup. So I can't tell you the benefits that this gives us. We can spin up containers really, really easily. We don't have to install SQL Server. We don't have to pray that Chocolate is going to install properly. We don't have to upgrade anymore. We don't have to install SQL upgrade files on a load of servers and get this instances upgraded. Another really cool thing as well is we can test new versions. SQL Server 2019 is in CTP at the moment, Community Technology Preview. In the olden days, I'd have to install that on a VM or install that on my laptop, install it, play around with it, and then blow it away when I finished. Not anymore. I can just pull down the new image, spin it up in a container, play around with the new features. When I've finished, blow that container away. My laptop hasn't touched. I don't have all these SQL binary files left here, there, and everywhere. My laptop stays nice and clean. So I hope that's given you a little bit of an overview of what you can do with SQL Server and databases running in Docker containers. A couple of resources for you. My GitHub there is DBA from the cold, Docker-databases. All the slides and the code for this session are on there. And then finally underneath, there's a link to my blog, which is a summary of each article that I've written about SQL Server running in Docker containers. Thank you very much.